All right, so we have 4 exponent x is equal to 20, okay? Now we can break down 20 as 4 times 5, or we can write 20 as 4 times 5. So our equation becomes 4 exponent x is equal to 4 times 5, okay? Now 4 here can be written as 4 exponent 1. So we can have 4 exponent x is equal to 4 exponent 1 times 5, okay? All right. Now that you can see 4 here and 4 here, we can divide both sides by 4 so that we can apply the quotient rule. Or we can divide both sides by 4 in order to apply the quotient rule. Okay? So you're going to have 4 exponent x is equal to 4 exponent 1 times 5. Okay? So let's divide here by 4 exponent 1, here by 4 exponent 1. So this and this will cancel. Okay? All right. So you're going to have 4 exponent x over 4 exponent 1 is equal to 5. Okay, so now we can apply the quotient rule. Now, before we apply the quotient rule, let's quote the rule, okay? So if you have a exponent m dividing a, or divided by a exponent c, you're going to have a exponent m minus c. Okay, can you see that? All right. Now you can use other letters, or you can replace other letters in the equation. Okay, I'm using A, M, and C, but you can use other letters as well. Okay, now equation is going to be 4 exponent x minus 1 is equal to 5. Okay, all right, so this is what we have now. Now, 4 can be written as 2 exponent 2, or 2 times 2 will give us 4. So in place of 4, we can write 2 exponent 2. All right, here we can apply another law of indices, okay? This is called the power of a power rule, okay? Now, if you're having a exponent m multiplying another exponent c, this can be written as a exponent m times c. So you're going to apply this concept to the left part of the equation. So you're going to have 2 exponent 2x minus 2 is equal to 5. Okay, it's equal to 5, okay? Now you can see still the base at the left side and the base at the right part are not the same. So what we do, we introduce logarithm, okay? So what we are going to do is to introduce log here and then do the same thing at the right part of the equation. All right, now, because we have introduced logarithm, we need to look at the specific rule of logarithm that's applied in this situation, okay? Now, if you're having log a exponent n to the base of b, this can be written as n log a base b. Okay, now let's apply this concept to the left part of our equation. So you're going to have 2x minus 2 log 2 is equal to log 5. All right. Okay, so you're going to have 2x minus 2. Okay, multiplying log 2 is equal to log 5. Okay, here we divide here by log 2, here by log 2. We are doing that because we want to move all the logs. We want to group the equation. Okay, so we are moving the logs to one side. Okay, all right. Now equation becomes 2x minus 2 is equal to log 5 over log 2. Okay, so this is our equation now. Now here we are going to introduce another law of logarithm. Okay, the change of base formula. Okay, or another rule of logarithm. Now if you're having log a over log b, this can be written as log a base b. Okay, log A with a base B. Now this is going to be, our equation is going to be 2x minus 2 is equal to log 5 base 2. So you can see that. All right. Now here we want to make s the subject. So we want to make x the subject of the equation. So we need to move anything that is attaching to x. Okay. So first we are going to move minus 2 to the right part of the equation. So here it becomes addition because it's crossing the equal to sign. Okay. So now we have 2x is equal to log 5 over 2 plus 2. All right. Now this is going to be 2x is equal to log 5 base 2 plus 2. Remember, we want to make s the subject. Okay. So here we can see 2 is attaching to s by multiplication. Because of that, we divide here by 2 and then divide here by 2. Okay, so our final answer becomes x is equal to log 5 base 2 plus 2 all over 2. Kindly subscribe to my channel. Support my channel by subscribing.